Hello everyone, welcome back. In this video, we are going to continue exercise 6.3 of lines and angles. We have already completed exercise 6.1 and 6.2. I have shared the links in the description. You can check out those videos and then you can continue with exercise 6.3. So now let's start. So before doing the exercise questions, we have to do two theorems whose results we are going to use in this exercise. So the first theorem is, which is theorem 6.7. The sum of angles of a triangle is 180 degree. See, we have this triangle ABC and we have to prove that, because for theorems we always do its proofs. So we have to prove that in this triangle ABC, the sum of the angles, I have already given the names to these angles, angle 1, angle 2 and angle 3. So basically we have to prove that angle 1 plus angle 2 plus angle 3 is equal to 180 degree. And this theorem is also known as angle sum property of triangle. And this result we can use while doing the questions of exercise. Now let's start. So theorem, always start by writing the given things. So here we have been given one triangle ABC. So we can mention triangle ABC. So one is angle A, another one is angle B and angle C. I have named these angles as angle 1, angle 2 and angle 3. Now if you want directly angle A, angle B and angle C also you can use, but this is a convenient way, that's why I have given names. Now next thing is to prove. This triangle we have to draw, because in theorems figures are not given to us. Now to prove, here we have to prove that angle A plus angle B plus angle C, it is equal to 180 degree. You can also mention as angle 1 plus angle 2 plus angle 3 is equals to 180 degree, because we have already mentioned the angles. Now here we have to do one construction also, so we'll mention that construction point also. So we have to draw one line XY which is passing from point A, and this line is parallel to BC side of a triangle. So we can mention XY through point A, or draw XY, you can write draw XY through point A such that XY it is parallel to BC. Now let's start with the proof. So in proof we have to start from here, since XY, okay, so we'll start from this line. See, XY, it's a straight line. The straight line, and if you see line XY, it is like this. This is XY, this is point A, and these are the points B and C. So here you can see it's a straight line and two rays you can see. AB is one ray which is standing on line XY, and AC is one ray which is standing on line XY. So here we can use the property or the linear pair axiom which we are using from exercise 6.1. So same concept we have to use here also. So first of all, if we consider this ray AB, so on AB, on XY line, ray AB stands, due to which the sum of these two angles, we only mention like this, sum of XAB plus BAY, it is equal to 180 degree, because it's a linear pair axiom. See, this is ray sharing common arm and common vertex, due to which they are making a pair of adjacent angles, and this scenario it is known as linear pair axiom. So we can mention, so on XY line, ray AB stands, or AB stands on line XY. This way you can mention Since AB is a ray, you have to show like this. AB stands on XY. XY is a line, we have to mention like this. Therefore, these angles, angle XAB plus angle BAY, it is equal to 180 degree. This is linear pair. See, this angle plus this angle, these two. Now, so here we can see AC is also there. So this angle, complete angle, we can just split it like this, BAC plus CAY. See, this complete angle, we can write it as a sum of these two angles. Same thing we are doing from exercise 6.1. Just this complete angle, we can write it as a sum of this angle and this angle. So BAY, we can, in next step, we can write XAB plus, instead of BAY, we can write BAC, angle BAC plus angle CAY. It is equal to 180 degree. So we can mention the reason also here, because angle BAY, it is equal to BAC, angle BAC plus angle CAY. So this reason we can mention. Now, because I have given the names as angle 4, angle 1, angle 5, so let's write down these values. XAB, it is equal to angle 4, so we can mention, instead of writing XAB, we can write angle 4. Then angle BAC, you can see this figure also, BAC, here I have given it as angle 1, so we can write as angle 1. Angle CAY is equal to angle 5, here also I can write, so it is angle 5, it's equal to 180 degree. So let's mark it as point number 1. Now we know that XY, it is parallel to BC. XY is parallel to BC. This is XY, this is BC. So only lines I am drawing. If I take this as a transversal, AB as a transversal, I have angle 2 and angle 4. X and Y, XY, it is parallel to BC. This is by construction. We can mention the reason also. XY is parallel to BC and AB, it's a transversal. Intersecting XY and AB. Now if you see angle 4 and angle 2, they are forming a pair of alternate interior angles. See, both angles are on the inner side of the parallel lines and 4 is on left side of the transversal and angle 2 is on right side of the triangle. So both of these angles are forming a pair of alternate interior angles, due to which these two angles are equal to each other, because alternate interior angles are equal to each other. So angle 4 is equals to angle 2. You can mention the reason, alternate interior angles. Now instead of ray AB, let's take ray AC. Now same lines XY and BC we have to take, but instead of AB we are taking AC as a transversal, and with AC we have angle 5 and angle 3. Same thing, now you can see XY is parallel to BC and angle 3 and angle 5. They are making a pair of alternate interior angles, both on inner side of the parallel lines and on opposite sides of the transversal. So you can mention similarly. If you want complete step also you can write, but similarly we can write angle 5 is equal to angle 3. Same reason, alternate interior angles. It's clearly visible, these two angles are alternate interior angles. Now we can see, we can rewrite our first point, angle 4 plus angle 1 plus angle 5 is equals to 180 degree. Now we know angle 4 is equal to angle 2 and angle 5 is equal to angle 3. So we can substitute the values of angle 4 and angle 5 as angle 2 and angle 3 in point number 1. So you can mention substitute the values of angle 4 and angle 5 as angle 2 and angle 3 in 1. So on substituting the values we will get angle 4 is equal to angle 2. Here we can mention it as point number 2nd and this as point number 3rd. Angle 1 as it is we can write, and angle 5 is equals to angle 3. So instead of angle 5 we can write as angle 3. So reason we can mention from 2nd and 3rd, because it's mentioned in 2nd point that angle 4 is equals to angle 2 and in 3rd point it's mentioned that angle 5 is equal to angle 3. So we have just substituted the values of angle 4 and angle 5 as angle 2 and angle 3. Now if you see angle 2 plus angle 1 plus angle 3, I can rewrite it as angle 1 plus angle 2 plus angle 3 is equals to 180 degree. So angle 1 is angle A, angle 2 is angle B and angle 3 is angle C. It's equal to 180 degree, and now you can see to prove angle A plus angle B plus angle C is equals to 180 degree. So hence proved. Now this result we can use while doing the questions of the exercise. Now let's do the next theorem. So theorem 6.8 is, if a side of a triangle is produced, then the exterior angle so formed is equal to the sum of two interior opposite angles. So I have this triangle ABC. If we are producing BC to point D, so this is exterior angle 4 will be formed. So I have named it as angle 4. So we have to prove that this angle 4, it is equal to the sum of two opposite interior angles. So opposite, we don't have to take this one. Opposite angles are angle 1 and angle 2. Interior angles means inside the triangle. So opposite angles are angle 1 and angle 2. So this thing we have to prove, angle 4 is equals to angle 1 plus angle 2. Now let's start by writing the given thing. So it's given to us triangle ABC, side BC produced to point D. Now to prove, we have to prove that angle A, this one, plus angle B, this is equal to angle ACD, because exterior angle, angle C, if we mention, it can be interior angle which I have named as angle 3, and it can be exterior angle also. So that's why full name we have to mention angle ACD, because exterior angle, or directly if you want you can mention angle 1 plus angle 2 is equals to angle 4. So this thing we have to prove. Now let's start with the proof. In triangle ABC, so here we are going to use the result of the previous theorem. So angle sum property of a triangle. So in triangle ABC, so directly I will mention angle 1 plus angle 2 plus angle 3, it is equal to 180 degree. So reason we can mention angle sum property of a triangle. Angle sum property of triangle, so which is the previous theorem. So we can name it as point number 1. Now if we see, BC is a straight line like this on which ray AC stands. So two angles are there, angle 3 and angle 4. So they are making a linear pair. So directly we can use angle 3 plus angle 4 is also equal to 180 degree because it's a linear pair. So angle 3 plus angle 4, because this thing we have used so many times, and now it's clear that these two angles, they are forming a linear pair and their sum is equal to 180 degrees. So directly we can use the result. We can name it as point number 2nd, and we can mention the reason also, linear pair. Now both point number 1 and point number 2, they are equal to 180 degree. If they are equal to 180 degree, which means they are equal to each other also. So from here we can mention from 1 and 2, angle 1 plus angle 2 plus angle 3, it is equal to angle 3 plus angle 4. So this is also equal to 180 degree and this is also equal to 180 degree. So instead of writing 180 degree, I have written these three angles, their sum is equal to the sum of these two angles. Now angle 3 is there in both the sides. So same thing will get cancelled if the same number with same signs, if it's present on both sides of the equation. So angle 3 we can cancel it directly, and after cancellation we will get angle 1 plus angle 2 is equals to angle 4. See, angle 1 plus angle 2, which is equal to angle A, have already mentioned angle A as angle 1 and angle 2 as angle B, and angle 4 is ACD, angle ACD. So we can mention hence proved. Sum of the exterior angle is equal to sum of the interior opposite angles is equal to the exterior angle. So this is what we had to prove, and this result again we can use while doing the questions of the exercise. Now let's start exercise 6.3. In question number first, this figure is given to us and it's mentioned sides QP and RQ. This QP and RQ, they are produced to points S and T respectively. PQ is produced to point S and RQ is produced to point T. If angle SPR, this angle is equal to 135 degree and PQT is equal to 110 degree, find angle PRQ. So this angle we have to find. So here also same way we have to proceed. First of all we have to write the given things. So given, we have been given triangle PQR whose sides PQ, say everything you can mention. So here I am just mentioning this triangle is given to us and these angles, angle SPR is equal to 135 degree and angle PQT, it is equal to 110 degree. To find, so what we have to find, we have to write that thing. So we have to find angle PRQ. So we can write angle PRQ. Now let's start with the solution. So PRQ, this angle which I have marked with green color, this angle we have to find. Now let's start. First of all we'll start with line TR. So TR is this line TR. Here ray PQ stands, you can see till here we can take, or PS also you can take, same thing, because basically we have to take these two angles. So on line TR, ray PQ stands, due to which these two angles, they are forming linear pair. So we can mention this thing. So ray PQ stands on TR. Therefore angle, so both the angles PQT, angle PQT plus angle PQR is equal to 180 degree. PQT, this one, PQT and PQR. So because they are forming a linear pair, that's why their sum is equal to 180 degree. So we can mention the reason also. So this will take it as point number 1, or no need to take, because we just have to find the value of one angle. See what we have to do in this question, we have to find this angle. So first of all we'll find these two angles. If we know the value of these two angles, then we can use angle sum property of a triangle to find the third angle of a triangle. So this is what we are going to do. Now by using this line and by using linear pair we have found the value of this angle. PQT, we know its value is 110 degree plus PQR, we don't know the value, is equal to 180. Now PQR will keep on this side, 110 will shift to other side, which will be changed to 180 minus 110, because plus 110 when we are shifting to other side it will be changed to minus 110. So angle PQR, it is equal to 180 minus 110, 70 degree. So we know the value of this angle now, which is equal to 70 degree. Now we will use this line SQ. See here, if I draw one straight line SQ, I am just rotating it towards left. So SQ, so here we can see this ray PR. So two angles are there, SPR which is equal to 135 degree, and the other angle is this one, which is RPQ, this one. So this we have to find now. So same thing, these two angles, they are forming linear pair. So same thing we'll use now. So we can mention on SQ, or ray PR stands on line SQ. Therefore angle SPR plus angle RPQ, it is equal to 180 degree. Reason we can mention linear pair. So now you are completely aware with the concept of linear pair, because from exercise 6.1 we are using it. See, on a straight line when a ray stands, the sum of the adjacent angles. See, adjacent angles, they share common vertex and common arm. So the sum of the adjacent angles is equal to 180 degree. Now SPR is equal to 135 degree, and RPQ we need to find its value, is equals to 180 degree. Since we need to find the value of RPQ, we'll keep RPQ on this side and we'll shift 135 to other side. So plus 135, on changing the side it will be changed to minus 35 degree. So 180 minus 135, it is equal to 45 degree. So angle RPQ is equals to 45 degree. Now we have two angles. We have angle P in this triangle. We have angle P also, and we know the value of angle Q also. So we can use angle sum property of a triangle to find the value of angle R. So here we can do in triangle PQR, we can mention angle PQR plus angle QRP plus angle RPQ, it is equal to 180 degree. See, all the three angles I have taken, PQR which means angle Q, QRP which means angle R, and RPQ which means angle P. So middle one. So full complete names I have written because the exterior angles are also there. So just to make it more clear, I have written the angles in this way. So we can mention the reason angle sum property of a triangle. So we have just now we have done this theorem. The sum of three angles of a triangle is equal to 180 degree, and this is known as angle sum property of a triangle. So we can fill the values now. PQR is equal to 70 degree. Angle QRP, we have to find its value, plus angle RPQ, it is equal to 45 degree, which is equal to 180 degree. Angle 70 plus 45 degree, it's equal to 115 plus angle QRP is equal to 180 degree. Now we need to find the value of angle QRP. So we'll keep QRP on this side and we'll shift 105 to 115 to other side. So 180 minus 115, because 115 on shifting to other side, it will be changed to minus 115. So angle QRP, it is equal to, we can do the subtraction now. So it is equal to 65 degree. So we have just used the theorem angle sum property of a triangle, and we know we have found the value of angle R, which is equal to 65 degree. Now let's do the next question. In question number 2, this figure is given to us and it mentioned angle x is equal to 62 degree. This angle and angle xyz, it is equal to this one complete angle, it is equal to 54 degree. If XO, if YO and ZO, this one, this line and this line, they are the bisectors of angle XYZ, XYZ and angle XY. One second, this is XZY respectively of this triangle. We have to find angle OZY, this one, and angle YOZ, YOZ. So these two angles we have to find. So bisector means, because these two are the bisectors of this angle and this angle, bisector means YO, it is dividing this complete angle into two equal angles, and which means this angle, it is equal to this angle. Same goes here also. ZO, it is dividing complete angle Z into two equal angles. Bisector means dividing in two equal parts. So we can start now. So we have to start same way. First of all, we have to write all the given things. Then here in given you can mention angle X. So whatever is given to us, same thing as it is you can mention. Now to find, in to find this thing, these two angles we can mention. Now let's start with the solution. So first of all we'll find, because we know these two are the bisectors of these angles. So first of all, in this angle, in this triangle XYZ, because we have or we know the values of two angles, angle X and angle Y. So let's find it out, the third angle, this one, by using angle sum property of a triangle. So we can write in triangle XYZ, angle X plus angle Y plus angle Z. So whenever I am writing this angle, because I am using triangle XYZ, so that's why complete angle we have to use, or we'll write complete angle. So XYZ plus XZY, it is equal to 180 degree. So we can mention angle sum property of a triangle. Angle sum property of triangle. We know the values of two angles. So angle X is equals to 62 degree, it's already given to us, and angle XYZ, it is equal to 54 degree. This is also given to us. So we can find the value of angle XZY, this complete angle, it's equal to 180 degree. So on adding we'll get, so 116 plus angle XZY, it is equal to 180 degrees. Since we need to find the value of XZY, I'll keep this on this side and we'll shift 116 to other side. So on changing the side, it will be changed to minus 116, because plus on changing the side it is changed to minus. So we can do the subtraction now. So it is 64 degree. So we know the value of angle XZY, it is equal to 64 degree. So now here we can mention also this is equal to 64 degree. We know the value of all the three angles of triangle XYZ. Now let's come to this triangle OYZ, because in this triangle we need to find these two angles, this one and this one. So before that, we can mention, because we know YO and ZO are the bisectors of angle XYZ and angle XZY. Therefore, so bisectors means this complete angle, it will be divided into two equal angles. So therefore we can mention, so angle XYZ, it is equal to this one, it's equal to angle XYO plus OYZ. This one, which is XYO, and this angle, it is equal to OYZ. See, and these two angles, XYO, it is equal to OYZ because of this, because YO, it's the bisector of angle XYZ, due to which these two angles, this one and angle this, both of these angles are equal to each other. So directly we can write angle XYZ, because we need this triangle now, so this one will use the inner one. So in place of, because both of these angles are equal, we can write OYZ plus angle OYZ, because these two angles are equal. So this also I have substituted by this. So angle XYZ, it is equal to 2 times of OYZ, or we need the value of OYZ. So this 2, because this is getting multiplied by this angle, so on changing the side it will get divided. So XYZ, half of angle XYZ is equal to angle OYZ. Now we know the value of XYZ, it is equal to, therefore this angle is equal to 54 degree, and we have to do its half. See here, I have just substituted the value of this angle XYZ, because half of this angle is equal to this angle. See, if these two angles, they are making a sum of complete angle, and then these two angles are equal to each other also. So if we do half of this complete angle, we will get the value of these two angles is equal to angle OYZ. So half, we can do the cancellation, so it is equal to 27. So this angle is equal to 27 degrees. You can do directly also. I have just shown you how this complete angle is, or how this smaller angle is equal to half of this complete angle. So similarly, because we know the value of this complete angle, since ZO, it's the bisector of this complete angle, which means this smaller angle, again it is half of this angle XZY. So same thing we are going to use again. So we can directly mention similarly. So these full steps no need to do now. So we can mention similarly angle OZY, it is equal to this one, angle OZY, it is equal to half of angle XZY, since this is a bisector. So same reason we can mention here, or we have already mentioned, so no need to write, because we have started YO and ZO are the bisector. So due to which OZY, it is equal to half of angle XZY. So we know the value of XZY, because at the starting itself we have calculated the value, which is equal to 64 degree. So half of 64 is equal to 32. So angle OZY, it is equal to 32 degree. Now in this triangle, so here we can mention in triangle OYZ, because we need to find the value of this third angle. So we can find it by using angle sum property of a triangle. We can use angle OYZ plus angle YZO plus angle ZOY, it is equal to 180 degree. Reason we can mention angle sum property of a triangle. So I have written in short, It's angle sum property of triangle. OYZ, OYZ it's equal to 27 degree. YZO it is equal to 32 degree plus ZOY, we have to find its value, it's equal to 180 degree. So 27 plus 32 it's equal to 59 plus angle ZOY. So we need to find the value of ZOY. This 59 will shift to other side, plus 59 it will be changed to minus 59 on changing the side. So angle ZOY it is equal to 180 minus 59. So we can do the subtraction now. So it is equal to 121 degree. So this angle is equal to 121 degree. So this is what we had to find. Now let's do the next question. In question number 3, this figure is given to us and it's mentioned if line AB is parallel to DE. This line AB it is parallel to DE at angle BAC. BAC is equals to 35 degree and angle CDE it is equal to 53 degree. Find angle DCE. So this angle we have to find. So same way we have to start. First of all we have to write all given things. So you can mention this is AB is parallel to DE, BAC is equal to 35 degree and angle CDE is equal to 53 degree. So this thing we can mention in given. Then the next step is to write to find. So we have to find angle DCE. So this you can write. Now let's start from solution. Now we know that AB is parallel to DE. This is already given to us. Therefore, angle BAE it is equal to angle AED. AED. I will draw here. These are two lines. This one is AB and this one is DE. And AE is a transversal also. So point A is here. So this angle and this angle AED. Angle BAE I have written and angle AED. These two angles. Since these two are parallel lines and AE is a transversal, so these two angles they are forming a pair of alternate interior angles. See, both the angles are on the inner side plus inner side of parallel lines and they are on opposite sides of transversal. So we can mention alternate interior angles because alternate interior angles are equal to each other. Therefore, angle AED it is equal to, because we know the value of BAE, it's already given to us. BA, C or E both is same because this is what we need. So BAE it's equal to 35 degree. You can also write it as BAC. Because here also if you write this line AC we are extending till point E. So same thing. Basically this is the angle which we need and this angle is equal to this angle because they are making a pair of alternate interior angles. So from here we got the value of this angle, angle E, which is equal to 35 degree. So we can mark it as point 1. It's not required also, but now let's move forward because we have to find this angle. So this angle is in triangle CDE. In triangle CDE, if I write angle C plus angle D plus angle E, it is equal to 180 degree. Reason is angle sum property of a triangle. The sum of all the angles of a triangle is equal to 180 degree. Angle sum property of triangle. So angle C we have to find, so we can write it as it is. Angle D is equal to 53 degree and angle E it is equal to 35 degree, which is equal to 180. Angle C plus 53 plus 35 which is equal to 88 degree, it's equal to 180 degree. angle C is equal to, because we need to find the value of angle C, so let's keep angle C on this side and shift 88 to other side. So it will be changed to 180 minus 88, because plus 88 on changing the side it will be changed to minus 88. So angle C is equal to, we can do the subtraction, 180 minus 88, so we'll get 92 degree. So angle C it is, we can also write it as angle DCE, full name also we can write DCE. So from here we got angle DCE is equal to 92 degree. So same way we have used the property of angle sum property, and we have found the value of angle C equals to 92 degree. Now let's do the next question. In question number 4, this figure is given to us and it's mentioned if lines PQ and RS they intersect at point T such that angle PRT this is equal to 40 degree and angle RPT is equal to 95 degree, angle TSQ it is equal to 75 degree. Find angle SQT. So this angle we have to find. So this is again very easy and simple question. So let's start by writing the given things. So given, again same thing, whatever is given to us you can mention. First of all the lines, these two lines they are intersecting, plus the values of all the angles you can mention. Then in the next step to find, you can write angle SQT. So directly I am going to start from the solution, but while doing you have to mention everything given to find or to prove everything, and if you are doing any construction also, that thing you have to mention. So solution. So now if we see in this triangle, so first of all, because we need to find the value of this angle, so in this triangle we need the value of this angle first, because two angles, angle P and angle R is given to us and the third one we have to find. So let's start. In triangle PRT, so we can write angle, so complete names we can write angle PRT plus angle RTP plus, so RTP which we have to find, plus angle RPT. See all the angles PRT, RTP, this one and RPT, all the three angles full names I have mentioned. Their sum is equal to 180 degree as per angle sum property of a triangle. So we can mention the reason also, angle sum property of triangle. So while doing these questions you have to mention each and every reason properly. Their sum is equal to 180 degree because of angle sum property of a triangle. So angle R it is equal to 40 degree. Angle T we have to find, so RTP we have to find, and angle RPT it's also given to us as 95 degree. It is equal to 180 degree. Now we can add these two. So RTP plus 40 plus 95 it is equal to 135, which is equal to 180 degree. Now we need the value of angle RTP, so let's keep RTP on this side and shift 135 on other side. So plus the 135 on changing the side it will be changed to minus 135. So 180 minus 135 it is equal to 45 degree. So we know the value of this angle, now it is equal to 45 degree. This angle and this angle, both of these angles they are making vertically opposite angles. See, theorem 6.1 we have already done while doing exercise 6.1. You can see these two angles are making a pair of vertically opposite angles, and we know that vertically opposite angles are equal to each other. So if this angle is equal to 45 degree, this angle is also equal to 45 degree. So we can mention the reason, angle RTP RTP, it is equal to angle STQ. So this one STQ, basically angle T on this side and on this side also. So this side it is STQ. So that's what I have written. So reason also we can mention, these are vertically opposite angles. So vertically opposite. So RTP is equal to 45. Therefore angle STQ is also equal to 45 degree, because we can mention the reason, because angle RTP, it is equal to 45 degree. Now in this triangle, because we need to find the value of this angle, we know the values of two angles within this triangle. So by using again angle sum property of a triangle, we can find the value of this angle. So let's start. In triangle QTS, any name you can mention, QTS or TSQ. So in this triangle, angle SQT, so this which we have already found, STQ, angle STQ plus the third angle which is TSQ. See, all three angles I have taken, SQT which we have to find, STQ which we have found just now, and TSQ, this one which is already given to us. The sum of all the three angles is equal to 180 degree. We can mention the reason, angle sum property of a triangle. So in short, I have written A for angle, S for sum, and P for property of triangle. So SQT we have to find, we can write it as it is, plus STQ which is equal to 45 degree, here also I have mentioned, plus TSQ, it's already given to us as 75 degree, it's equal to 180 degree. Now STQ, it's equal to 45 plus 75 so it's equal to 120 is equal to 180 degree. Now we need to find the value of SQT. So let's write SQT on this side and shift 120 to other side. So on shifting or changing the side, 120 or plus 120 will be changed to minus 120. So 180 minus 120 is equal to 60 degree. So we found the value of SQT equals to 60 degree. So this is what we had to do. Now let's do the next question. In question number 5, this figure is given to us and it's given if PQ is perpendicular to PS. This PQ is perpendicular to PS. The sign of perpendicular is also given to us. Then SQR. So this means it is making an angle of 90 degree. So this is, here also I'll write 90 degree. PQ is parallel to SR and it is parallel to SR, this line. SQR, this angle SQR, it's equal to 28 degree, and QRT it is equal to 65 degree. Then find the values of X and Y. So this is X and this is Y. We need to find the values of X and Y. Again, you have to write given. In given you can mention everything starting from here till here. So given you have to mention this till here, then to find. So in to find you can mention to find the values of X and Y. Now let's start. So you have to write everything. I am starting directly from solution. So here this triangle is there, QSRT. So this angle is equal to 65 degree. So if you see there are two ways by which we can do this sum. Either we can do alternate angles, because this line it's parallel to this line. So due to which this angle and this angle, complete angle, they are making a pair of alternate interior angles. And also we can find the value of this angle, this one. And because this angle it is equal to 28 degree, it's already given to us. So I am going to use exterior angle property. The reason is that we have done theorem also. So I am just explaining you, you will get the same values. If you want, you can apply here that this angle QRT, and angle this one PQR, this complete angle, they are equal because they are making a pair of alternate interior angles. And then you can solve the value of x. And you can also use, which I am going to do now, and this one plus this, their sum, it's equal to 65 degree. Why? Because of exterior angle property of a triangle. We have already done the theorem that sum of opposite interior angles is equal to the exterior angle when this line is produced. So according to that, this angle QSR plus angle SQR, it is equal to 65 degree. So we can write also in triangle SQR. So this triangle we are taking angle SQR plus angle QSR. Here you have to take, see, don't take adjacent angle, this one which is near, which is the touching angle or which is sharing common arm and common vertex. You have to take the opposite angles, and opposite angles are these two angles. So that's why angle SQR, which is this one, plus angle QSR, this one, these two angles, their sum is equal to angle QRT. We can mention the reason, exterior angle property of a triangle. This way you can mention exterior angle property of a triangle, or you can also mention the full theorem that the sum of the opposite interior angles is equal to the exterior angle of the triangle. In this way also you can mention sum of two interior angles is equal to exterior opposite angle. In this way also you can mention directly exterior angle property of a triangle. So SQR it is equal to 28 degree, it's already given to us, plus angle QSR. We don't know the value of this angle QSR, this one is equal to QRT, it's equal to 65 degree, and this is also given to us. So angle QSR we need to find, we'll keep this angle on this side and shift 28 to other side. So on shifting the side or on changing the side, plus 28 will be changed to minus 28. So 65 minus 28 is equal to 37 degree. So angle QSR here I will write, because in this figure it's given, so it is equal to 37 degree. Now we know the value of this angle. Again we can use the concept of alternate interior angles, because this side it is parallel to this side and this is a transversal like this. See, PQ, it is parallel to SR, and this transversal will take QS. So this is one angle which is equal to 35 degree, and this is X. See, I'm not drawing this, only the required part I have drawn to make things clear to you, that this angle and this angle which is equal to X, they are making a pair of alternate interior angles. You can see both of these angles are on the inner side of the parallel lines and opposite side of the transversals, due to which they are making a pair of alternate interior angles. So here we can mention, so after this we know PQ, it is parallel to SR, it's already given to us. Therefore angle PQS, this one PQS, or from here also you can see PQS, it is equal to angle QSR or QSR, alternate interior angles, because alternate interior angles are equal to each other. So PQS, it is equal to X, so we can write its value. Say PQS, it is equal to X, and QSR it is equal to 37 degree. So that is what we have to find, X is equal to 37 degree. Now the next thing is to find the value of Y. So Y, the concept which we have learnt after starting this exercise is angle sum property of a triangle. Now if you see this triangle, here I will draw, this is the triangle which is PQS. Here this one angle is 90 degree, other angle is X which we have found as 37 degree, and the third angle is Y. So the sum of all the three angles of a triangle is equal to 180 degree. We will use angle sum property of a triangle and we will find the value of Y. So we can start in triangle PQS, angle QPS plus angle PSQ, see QPS PSQ plus angle SQP, it is equal to 180 degree. So we can mention it is because of angle sum property of a triangle. So you have to mention completely. I have written in short angle sum property. Now QPS, it is equal to 90 degree. We can write the value PSQ, it is equal to Y. So we can write it as Y, and SQP which is equal to X, and X we have found as 37 degree. So directly 37 degree we can write. It's equal to 180 degree. So Y plus 90 plus 37, it is equal to 127. It's equal to 180 degree. So Y we need to find. So we'll keep Y on this side and shift 127 to other side. So on shifting to other side, it will be changed to 180 minus 127. So 180 minus 127 is equal to 57. So Y is equal to 57 degree. Yes. So we have found the values of X and Y as 37 and 57 respectively. Now let's do the last question of this exercise. Okay, so Y is after, so by mistake I have written 57, it is equal to 53, because 180 minus 127 is equal to 53. Now let's do the last question of this exercise. In this question, this figure is given to us and it's mentioned the side QR of triangle PQR. This is triangle PQR and its side QR, it is produced to point S. If the bisectors of PQR, so this is PQR, its bisector. Bisector means the line which is dividing this angle PQR into two equal parts. So the bisector of PQR, this angle, and PRS, this angle. So this one and this one, their bisectors, they are meeting at point T. See, because this line, this angle PQR or PQS, it is bisected by QT, and then PRT, its bisector is TR, and both of these lines, they are meeting at point T. So we have to prove that angle QTR, this angle is equal to half of angle QPR, this one. So this thing we have to prove. So let's start with the solution. Same way you have to proceed. You have to write given things. First of all, given things, see, complete statement till here you have to write. Starting from here till here you have to write in given. Then here we don't have to find anything, we have to prove. So to prove this thing you can mention. Now let's start with the proof, because here we have to prove this thing, so we have to write proof. First of all, we'll use this triangle, this one PQR, and here we are going to use exterior angle property of a triangle. So in exterior angle property, the sum of two interior opposite angles of a triangle, it's equal to the exterior angle. So we can mention also, so angle QPR plus angle PQR, which are interior angles. See, these two are the interior opposite angles, it is equal to angle PRS. And we can mention the reason also, exterior angle property of a triangle. According to exterior angle property, the sum of the interior opposite angles, it's equal to the exterior angle formed with the same triangle. So this, if you want full statement also you can mention, or you can also mention on the exterior angle property, so it's fine. Now divide this equation by 2, or divide both the sides of the equation by 2. So both the sides, because I have already told you, whenever you are making any change within this equation, you have to make that change on both sides of the equation. So whenever you make change on both sides, it won't create any difference. So divide by 2, we can do it now. Half, division means this sign, so dividing by 2 means multiplying by half. So same thing. So half QPR plus half angle PQP PQR is equals to half angle PRS, because bisectors are given to us, that's why we are using this thing. Now half of angle QPR, so this we can mention as it is, half of angle QPR, because QPR is this angle and no bisector is there. Now half of angle PQR, half of this angle. We know this angle and this angle, they are equal to each other, because QT is the bisector of this angle, it's already given to us. So half of QPR, either we can mention this angle PQT or we can mention as TQR. So afterwards we have to use this triangle, so that's why we are going to use TQR. So half of this complete angle PQR, we will write it as angle TQR. Since this is the bisector, see this line QT is dividing this angle into two equal parts. So complete angle, if we have to write its half, we can write it as TQR. You can write PQT also, but afterwards we have to use this triangle to make angles same. We are using this angle. So you will come to know. And half of angle PRS, half of angle this angle, because this is the bisector, this one. RT is a bisector of this angle. So again we will use this one, because we are going to use this angle in the next step. That's why here we will use this angle, because for this triangle this is the exterior angle. So half of this angle PRT, we will use it as TRS, angle TRS. This is point number 1. See, half means, because this is the bisector, that's why this angle and this angle, they are equal to each other. If total angle is 80, then this will be 40 and this will also be 40. So that's why we have used this thing. Now let's use the other triangle. So same property, exterior angle property we have to use, but the triangle will be different now. It is TQR. Earlier we have used this one, now this one we are using. So now this is the exterior angle for these two interior opposite angles. So we can mention now for triangle. So this first step, in triangle TQR, angle TQR plus angle QTR. See, this angle TQR and QTR, these two angles I have taken because these are interior opposite angle, is equal to angle TRS. This is the exterior angle. So according to exterior angle property, sum of the two interior opposite angles is equal to the exterior angle of the triangle. So this theorem we have already done its proof at the starting of the exercise. So now that result we are using. So this will mark as point number 2. So from first and 2 you can see TRS, both of these things they are equal to TRS. So we can write here from first and 2, because we are getting from first and 2, from point number 1 and 2, half angle QPR plus angle TQR, it is equal to angle TQR plus angle QTR. See, because this is also equal to angle TRS and this is also equal to TRS, which means both of these they are equal to each other. See, when the thing is common to one, when the thing is equal to one common thing, they will be equal to each other also. So this and this is equal to each other. Now if you see this equation, we can see TQR is present on both the sides with same sign plus. So whenever any number or anything is present on both the sides of the equation, that thing will get cancelled directly. So now we got half of QPR is equal to angle QTR, or we can rewrite it as angle QTR is equal to half of angle QPR. See, this is what we had to prove. The QTR is equal to half of angle QPR. So with this chapter is completed, and we have done all the proofs of all the questions along with proofs of all the theorems. If you like the video, do share, do subscribe. Thank you so much for watching the video, and I'll see you in my next video with some new topic. Thank you.